Okay, so question 2. Loads of information, loads of stuff here. Jump straight to the question with the bit with the number and the letter next to it. State what is meant by the moment of a force. Well, the moment. So people often get confused by the word moment, but all it means is what is the turning moment. So the moment of a force is what is the turning effect of the force. So don't think of it as the word moment, think of the word turning moment, because then it makes more sense. Foot pedal is pushed halfway down and held stationary. The toe and the chain both exert a force on the foot pedal. Compare the sizes and direction of the moments caused by the force of the toe and the force on the foot chain. Okay, well the first thing you know is it's held stationary. Okay, so whenever I read a question I'm looking for clues like held stationary, in equilibrium, balanced, no acceleration, those kind of words, they tell me something about the moment or the force, depending on which one it is, which we're talking about. But because we're talking about moments here, because it's stationary, that means that the moments must be balanced. So sizes and directions of the moment. So they must balance and acting in opposite directions. Okay, so if I hadn't done both of those two things, I'd probably drop this mark, which is a bit harsh, a bit more marker for this. But that's the way it is. Okay, so the drummer's toe pushes with a force of 1.5. Now for this, I would draw a diagram. So it says it's pushing down with 1.5 newtons. And it's the perpendicular distance, so the force is 0.12. And so the perpendicular distance from the pivot to the chain is 0.20. Calculate the force of the chain acting on the foot pedal. Okay, so I've rewritten that information into a diagram here, just makes my life a lot easier. I know that the moments are balanced, so I know that this one here is my anti-clockwise moment. I know that this one here is my clockwise moment. I know the two are equal, so 1.5 times 0.12 equals 0.2 f, which means that f equals 1.5 times 0.12 all divided by 0.2. Okay, that's worth 3 marks. Look how easy that is. Basically just give me the marks away. I'm just doing it on the calculator now just to give you the correct answer. I would if I could work my calculator. So I make that 0.9. Part B. Again, loads of information, don't bother reading it. Jump straight down to this bit here and then go back up with a bit of context. This bit here gives you the context with which you can use to read the rest of the question. So if I was reading this question, I'd say, how does the length of the drumstick lever affect the variation in loudness of the sound from the drum when applying a 3 Newton force? Okay, so now I know I'm looking for a 3 Newton force, and I'm looking at how length affects it. Okay, so what I can see is, I can see that here, look, length is increasing, and here, look, I can see this one's for 9 newtons, this one's for 6 newtons, this one's for 3 newtons. So I can see that as the length increases for 3 newtons, then the speed decreases. Can I tell you anything about? The highest, and then here, look, and now I need to go back up, so I say, okay, but in that case I want to know what, I need to know more about speed, don't I, because it's asking me about loudness. So it says the higher the speed at which the beater hits the drum, the louder the sound the drum makes. So for a force of 3 newtons, the higher the length, the faster, so the louder it gets. Okay, so now I can't take all of that in, and all of this in, and all of this in, all in one go. It's too much for me. But if I know that I think, okay, I'm only going to look at the 3 Newton bit here, and then I go, okay, I'm only going to care about how does length affect loudness. Okay, well, I know how length affects speed, so I best read this bit to find out how speed affects loudness. And that's how I broke that question down. Okay, next bit, a range of forces from 3 newtons to 9 newtons. So sorry, I've got it wrong. I've read the graph wrong, completely wrong. On this first one, look, you can see it's getting slower as it gets longer. So the higher the length, the slower. So the quieter, completely the other way around. Apologies, I don't know why I did that. It's going downwards. And then from 3 to 9, you can see that it doesn't matter which one you go to, 3 to 9, this one's always lower than this one's always lower than this one. So you know that it's always faster the more force. So the greater the force, the faster, so it is louder. So it gets louder as it goes from 3 newtons to 9 newtons. That's a lot of information for 2 marks.